So the first thing we're going to look at here is our input file, and hopefully this allows you to understand the problem that we're solving today with Seeker. Again, we're doing a stochastic production problem. So we're pretending that we have a sushi restaurant and we are producing different kinds of sushi. Meinolf has a good video on this, which you can also watch, about sort of how the nature of the problem and how stochastic optimization can help solve it. So here we have different products that we produce, which are things like chirashi bowls, sashimi boats, and sushi platters. And each of these things has a cost for production, which we lose if we produce something and nobody buys it, and then a profit if somebody actually does buy it. So I might make a chirashi bowl. If nobody wants it, I lose $4.32. But if somebody does buy it, then I net gain $3. And we have minimum and maximum production values for each of these products. Each product takes some sort of resource or combination of resources, and we have constraints on those resources. So for example, we have tuna, and a chirashi bowl takes 2 units of tuna, whereas a sashimi boat might take 5. And we have 10,000 total units of tuna. And the same with salmon, cucumber, razor clams, and rice. And all of these resources constrain the products that we can create, right? So we can't produce products when we don't have the resources for them. Finally, we have our forecast, and this is where things get really interesting. So you might say, in a typical production problem, we'd have a point estimate on the amount of demand that we're trying to meet. So I would produce, say, 300 units of X and 800 units of Y. But in the real world, we, of course, have uncertainty. And so what we're doing here is saying we have a point forecast, which is 300 units of chirashi bowls, but there is noise around that point forecast. So we have here a normal distribution where we describe what the error is on that forecast. And we're going to use that directly in the model. So let's look at the code for the model itself. So first we have, this is Python using the Seeker APIs and the NextMove APIs. So the Seeker APIs are going to handle the optimization, modeling, and solving part of it, and the NextMove APIs are going to handle the deployment, data loading, and everything that goes around it. So here we have the NextMove APIs where we're pulling options out of the NextMove cloud or the command line environment, which do things like tell us how long the solver is allowed to run for, or what the resolution is that we want to pass to Seeker, which is sort of a way of thinking of how many scenarios, random scenarios, Seeker is going to sample. We also have things like how frequently to report on the best solution, what the scenario seed is for randomly generating those scenarios, and what the solver seed is for directing the search. And we load that along with all the data down here. Once we have our parameters and our input data, now we're going to construct the model. And so you can see here we're setting up a Seeker environment. We are turning on stochastic parameters with resolution and speed settings that we get from the command line or NextMove cloud. And we're creating decision variables for each product. So for each product, a chirashi bowl, sashimi boat, and so on, we have a variable here, which is how many units of that to create. And here's where the magic happens. So now what we're doing is creating a demand term, which is that point forecast. So, for example, 300 chirashi bowls with a normal distribution around it. And Seeker is now going to sample from this normal distribution to sort of represent uncertainty in the problem. From that term, we also derive our sales and waste, and then finally our profit. And so our profit is essentially how much we're getting versus the costs that we pay for wasted resources or wasted products. And it aggregates those into the mean. So we are maximizing the expected return. Finally, we add our resource constraints. We can't make things if we don't have the resources for them. And we call Seeker to optimize and then get output. And so here we have on our solution output, how many of each product to make, what the expected demand is going to be for different scenarios, and sales and waste, as well as some metadata and statistics from Seeker. All right. So once we have that written, we can push it into the NextMove environment with a simple NextMove app push command. And this will push this into NextMove Cloud where we can run it and we can do scenario tests and lots of fun things like that. All right, we've pushed it. It is now live and it has an endpoint assigned to it so we could make requests to our application. Once we go over into NextMove Cloud, we can see that it has endpoints associated with it and API references. Let's look at a specific run. I'll just load this one that I've already done. And we can see here's some metadata about the run, how long it took, what kind of instance it ran on. This was running inside of a Lambda function. We can see statistics about the run, what was the value, how many constraints and how many evaluations did Seeker do, so on and so forth. We can see configuration that we passed to it. So I let it run for 30 seconds. I've set the resolution to 25,000 and so on. We can retrieve the input. So this was a slightly larger version of that input where we also have things like yellowtail sashimi and tempura shrimp rolls. And we can get the result from it, which tells us how much of each product to make, what our expected demand, sales, and waste are. And then we can also get the logs from Seeker. So here we can see that Seeker is improving the solution over time and doing lots of different evaluations and whatnot. We can also run large-scale tests with things like scenario tests. So I'll bring up one that I've already run, which is here. And what we did here was create a bunch of different scenarios where we varied the number of resolutions, i.e. the number of scenarios that Seeker would pull out of its random distributions. And we gave it the same scenario seed. So what this essentially means is we are generating the same scenario and then trying to optimize it with different samples, different numbers of samples. And we get a pivot table output from all of these runs. And so I think this resulted in about 100 runs. And if I pull out some of these values from the pivot table, I can see that we're getting different values and different estimates based on the number of scenarios. There's different levels of uncertainty there. I can also turn this into something like a line chart if I want here.